Welcome to solverfy.
Hello there. In this exercise, we need to count how many functions, one-to-one functions, or also you can call it injective functions, uh, are if this function map from a set with 5 elements to, and we have here some possibilities. So what happens if, how many of those functions are if we map from a set with 5 elements to a set of 4 elements? Well, here there is no such functions, because you can imagine in this way. Here you have 5 elements, 1, 2, 3, 4, 5, and here you have only 4 elements, 1, 2, 3, 4. So the point to be a one-to-one function means that each element here should be assigned with only one on the target. 1, 2, 3, 4, and then the remaining one should be related to one with other element here that's going to be repeated, and this is a contradiction for a one-to-one function. Technically, you can verify the meaning of one-to-one function can be verified that if f of x1 is equals to f of x2, that implies that x1 is equals to x2. But in this case, you can see that that is not satisfied, because here these two different functions, these two different points are mapped to the same value, but those are not the same, or they are different. So that's why this is a contradiction, this from the mathematical point of view. And so there is no such function, so no f in this case. What happens if you have 5 elements? So now you can start to count. And the idea here is that you can see this in the following way. So you can see that the domain of this function as wholes. And you're going to, of course, assign one whole to one element in the target. Okay? But in the target, you're going to have some elements, right? So for each whole here, you can assign any of these 5 possible elements in the target set. So you have, in summary, you have here 5 wholes, and you at the first whole you have 5 possible elements. But this function is one-to-one. That means that these elements cannot be repeated. We cannot assign the same whole to 2 elements on the other set. So if you assign one element to this first whole, okay, then you cannot assign the same element to the second one, or you cannot assign the same element to the second to another element in the domain. So now here you have 4 possibilities, and then for the rest you have 3 possibilities, and for the next you have 2 possibilities, and for the last one you have only 1 possibility. So you have all these possibilities for each place to assign to each element on the domain of this function. Okay, so this is going to be the domain. This is the codomain or range or target, whatever. So the point is that you have these possibilities for each location or for each element in the domain. That means 5 times 4 times 3 times 2 times 1, which is equals to 5 factorial, and that in this case is equals to 120. Okay, so you can think in this way to do this kind of counting with functions when you have onto functions, or one-to-one functions, or bijective functions. So now let's suppose that the target set has 6 elements. So in this case, now you following the same procedure as before. To each element in the domain, these are elements in the domain, we have 5, but for the first one we can assign 6 from the range. For the second element we can assign 5 possibilities, and then 4, 3, and 2. Okay, so you can think this thing of functions to calculate how many functions is similar to locate 6 elements on 6, for example, balls or any element on boxes. Okay, or holes is the same analogy. So the holes are going to be the elements on the domain. So in this case, we have 5 boxes where we're going to locate these 6 elements, and these elements are not going to repeat, so it's not allowing the repetition. So in the first box you can put 6 of these elements, on the second you have 5, and so on. That is the same that I'm doing here. So in general, you can calculate the number of injective functions or onto or one-to-one functions just by knowing the number of elements in the domain. So let's say that this map from a set A to a set V, and the number of elements in A is equals to n, and the number of elements in B is m. Okay, so all the possible mappings, all the possible functions that are one-to-one, that map from A to B, and the numbers of elements are n and b respectively, is going to be equal to m factorial divided by m minus n factorial, and it's necessary that n should be less or equal than m. Okay, so there's the condition, and this is the formula. So that I'm giving here the general formula for this kind of exercises. So in this case, the m is equals to 6, and the n for all these exercises is going to be equals to 5. So you can see that this is going to be 6 factorial divided by 6 minus 5 factorial, and the end it is just 6 factorial, that is equals to 6 times 5 times 4 times 3 times 2 times 1. That is the same that we have here, as you can observe. And the value is 720. And knowing this formula, then the last one is immediately. So now the range or the target set has 7 elements. So we follow the formula. So it's 7 factorials divided by 7 minus 5 factorial, and this equals to 7 factorial divided by 2 factorial, and this equals to 7 times 6 times 5 times 3 times 2 times 3. Yeah. Here I remember 4 times 3. Yeah, that's it. And this equals to 2520.